Good morning, everyone. Myself, Prabharan working as an assistant professor in EC department at SNS College of Technology. In this lecture video, I am going to discuss about the topic name is Rules of Block Diagram Algebra from Unit 1, which is Control System Modeling. From the subject name is Linear Control Systems. Let I discuss the rules of block diagram algebra, which is an important topic in control systems. These rules help us simplify complex block diagram and determine the overall transfer function of a system. In a block diagram, the flow of information is always unidirectional. This means signals move only one direction, that is from input toward output. The output of each block is equal to the input multiplied by the transfer function of that block. Let me see the definition. The block diagram algebra is defined as the ratio of the Laplace transform of output to the Laplace transform of input. Assuming all initial conditions are zero, this assumption simplifies analysis and make mathematical modeling easier. Let me discuss the rules of block diagram. The first rule is combining blocks which are in cascade or in parallel. When blocks are connected in cascade, we multiply their transfer functions. When blocks are connected in parallel, we will add their transfer function. This helps to reduce multiple blocks into a single equivalent block. Here you can see the diagram for first rule. And second rule is moving a summing point behind a block. If we move a summing point behind a block, the signal passing through must be divided by block transfer function. Let me see the third rule. The third rule is moving a summing point ahead of a block. If we move a summing point ahead of a block, the signal must be multiplied by the block transfer function. And fourth rule is moving pick up point behind a block. When we moving pick-off point behind a block, we multiply the branch signal by the block gain. And fifth rule is moving a pick-off point ahead of a block. When moving it ahead of a block, we divide the signal by the block gain. You can see the block diagram of third rule and fourth rule and fifth rule on your screen. Let me do one small activity. The activity question you can see on your screen. You have to find the value of question mark. Let me discuss the sixth and seventh rule. The sixth rule is nothing but the eliminating the feedback loop. A feedback loop can be eliminated by using closed loop transfer function formula. You know the open loop transfer function is nothing but the g of s. The closed loop means the feedback gain is nothing but the h of s, and unity feedback gain which is equal to 1. Okay, here you can see the diagram. And seventh rule is swapping with two adjacent summing points. Two adjacent summing points can be interchanged without affecting the response. And next is we will see the summing point concept. Here you can see the diagram. A summing point is a junction where signals are algebraically added or subtracted. The sign shown at the summing point determine whether the signal are added or subtracted. Yeah, let I check your understanding. Here we have a one small assessment quiz. First quiz is the main purpose of a block diagram algebra is control system is to which one is correct? Option A, option B, option C, option D. The correct option is option B. Simplify system representation and find overall transfer function. This is the correct answer. And let me see, move to second question. When two blocks are connected in cascade, their equivalent transfer function is which one is correct? Option A, option B, option C, option D. Option C is correct, product of transfer function. Option first question option B, second question answer is option C. If you have any doubt, you can ask me through the comment. We will meet in next video. Thank you.